committee of 4 is chosen from 7 men and 6 women. How many different committees can be chosen if A, there are no restrictions, B, there must be 2 of each sex, and C, there must be at least 1 of each sex. So you notice these are combinations rather than permutations, because once you've got that group, the order within that group doesn't matter. So I'm literally just selecting a group of 4, and they come as a pool of people, so it's not important. Is one's member 1, member 2, member 3, member 4. It does not matter at this stage. So part A, all we need to do is select 4 people from all the people available for selection. So that's the 7 men and the 6 women. So there's 13 people you're selecting from, and you need to select 4 of them. So you need to choose 4 from 13. So I think that's kind of 13 choose 4. You choose 4 people from 13 people. So I would do that on a calculator, and 13 C4 is 715. So that's 715 different ways. Remember, on your calculator, if it's a Casio, you need to go to option and look for the probability bit. That will be on the next screen. And on the TI-84, you need to go to math and look for probability, and you will find it there. Part B. So now we're bringing in some restrictions. There must be 2 of each sex. So that means the committee is made up of 2 men and 2 women. So you're choosing 2 men from the 7 available. So from 7 men, you're choosing 2 of them to be in the committee. And from the 6 women, you are choosing 2 of them to be in the committee. So the number of ways you can choose 2 men from 7 is the answer to that. The number of ways you can choose 2 women from 6 is the answer to that. So the number of ways they can occur together, remember it's this fundamental principle of counting, or the product principle. If you multiply these together, it will tell you how many ways they can happen together. So you don't really need to know the individual answers, but I'll write them down anyway, just using a calculator. This is 21, 7C2 is 21, 6C2 is 15, and 21 times 15 is 315. So you can see there's a lot less, once you get restrictions in, you notice that there's much less possibilities for different committees. Part C, we've got sort of slightly more complicated restrictions. So it says there needs to be at least 1 of each sex, so at least 1. So what that means, there's 2 ways to go about this. You could think about the opposite. I'm not going to do that straight away, but you could say, well, what if there was 4 women on a committee and no men, or 4 men and no women? And then you could say, well, that's the only way this can't happen. And then you could subtract from the total. So that's not a bad option. I'll show that in a minute. Or then if you think, how can you make different ways that you can make this happen? So that would be, well, you could have 3 men and 1 woman. So that would mean you're selecting 3 men from 7, and you're selecting 1 woman from 6, and you're multiplying them together. So this is 3 men and 1 woman on your committee, right? Then you could also have the other way around. You could have 1 man and 3 women. So you could select 1 man from 7 and 3 women from 6, and then you could times them together, because the fundamental principle of counting tells you to do that. So this is 1 man and 3 women. Or you could have, well, what we've just had with 2 and 2. So you could have 2 men and 2 women. And again, fundamental principle of counting. And whenever you say or, that means add. If it's going to happen in different ways, you need to add those different methods together. So this calculation will tell us, because we can form this committee with at least 1 of each sex. We can do it in this way, or this way, or this way. So we can have 3 men, 1 woman, 1 man, 3 women, and we can have 2 of each. So or. I keep saying and, it shouldn't be and. The and is about this. This is the number of ways they can both happen together. So we already had the answer to this bit, which was 315. For the other two, I'm just going to go to the calculator. So 7C3 is 35 times 6C1. Anything C1 is just the number itself. And then 7C1 there must be 7, and 6C3 is 20, and then we know it's 315 just using the answer to part B. So if we add all of those up, that comes to 665 possible committees. So it's quite a lot, but it's still not as many as the total number of possible committees if there's no restrictions at all. Now, I was just speaking earlier, you could go about this a different way, and it's for these questions it's good to have as many tools up your sleeve as possible, because when they get more difficult, you do really need to be armed with lots of different techniques. We'll hopefully get a few done today, and maybe might need tomorrow as well. But the other way around this was saying, well, how could this not happen? This is very similar to probability, kind of got and, or, not. And is where this times sign happens, because this way can happen and this way can happen, so a number of ways they happen together. Or is when you add, so and is times, or is add, and not is where you take away. So if we have the number of the ways this thing can not happen, you take them away from the total. So basically, how could this not happen? Well, that would be if you had an all-male committee or an all-female committee. So you might say, well, that would be 4 men from 7 times no women from 6, or, well, you could say, well, this could also, you could have the exact opposite. You could have no men on the committee and 4 women. So this is how you could have not at least one, and if I'm then using the not rule, I could get all those combinations and take those away from the total number of committees with no restriction, which was 715. And you should find that that still leaves you with 665 possible committees when there's at least one of each sex.